Hello, in this lesson, I want us to look at some advanced trigonometry. And under advanced trigonometry, we are going to look at compound and multiple angles. The function A cos theta plus B sin theta. Okay, so the question that we have says, convert 3 cos theta plus 4 sin theta into r sin theta plus alpha. Okay, so the way we convert here, we have to find the value of r and also the value of alpha here. And so here is how we do it. So we are going to expand this one here by using the trigonometric identities that we know for sine. So we are going to have r. When we expand here, we are going to have sine theta cos alpha plus sine alpha cos theta. Okay, so which when we distribute the r here, we are going to have r sine theta cos alpha plus r cos theta sine alpha. So we've just interchanged these two here and written it in this form. And then when we reach this point now, since these two are supposed to be identical, this one and the one that we are given here, so we are going to look at this one, the one we have found here, and compare it with the one that we have there. So when we look at this one here, this one has 3 cos theta. So we'll look at both sides of the expression to see which one has cos theta. So you notice that this one on the right side here has cos theta. So we are going to have 3, this one, 3 cos theta is equal to this part of the expression here, which is r cos theta sine alpha. And then we can cancel out the cosines. So this cosine will cancel with that cos theta there. The cos thetas will cancel, and our expression will remain r sine alpha is equal to 3. And so we can do the same even now on this other side of the expression, the one that has sine theta. We can compare it with this other part which has sine theta. So we are going to see that in the same way, sine theta will cancel with that sine theta there, and you remain with a 4 here, and here you remain with r cos alpha. So the second one will be r cos alpha is equal to 4. Okay, so now with these two equations, let me label this one as equation number 1 and this one as equation number 2. With these two equations, we can find the value of alpha and also of r here. So the first thing that we are going to do, we are going to use the identity for tan. Tan, where we divide sine and cosine. So we'll divide these two equations. So equation 1, which has sine, will be on top, and equation 2, which has cosine, will be down. So we are going to have r sine alpha over r cos alpha is equal to 3, r sine alpha is 3 over 4. And so when we cancel the r's here, we remain with sine alpha over cos alpha, which gives tan. So we are going to have tan alpha is equal to 3 over 4, which can also be written as a decimal number, which is 0.75. And then we can find alpha here. Now alpha is equal to tan. We find the inverse of 0.75 or 3 over 4. And so when we apply our calculator, we are going to find what alpha is. So on the second function there, we can find the tan of 0.75, and we are going to have 36.87. Okay, 36.87 degrees, which we can round off to 36.9 degrees. 36.9 degrees is our angle, and now since we have our angle, we can now find our r. Okay, we can now find our R. We can now find our R by using the two equations that we have, equation 1 and equation 2. By using the two equations that we have, and here is how we use. So here, for us to find our R here, we are going to use this identity. The identity is sine squared alpha plus cos squared alpha is equal to 1. So sine squared plus cos squared is equal to 1. This one is a very important identity in trigonometry. Every student of trigonometry must know this identity. And so here is how we apply it here. We have these two equations here. We are going to square both of them and add them. So R, equation 1, R sine alpha in brackets squared plus R cos alpha squared is equal to, remember R sine alpha here is 3. So 3 squared plus 4 squared. So we are squaring even on this side of the equation. So we square both of them and add them. So here we are going to have R squared sine squared alpha plus R squared cos squared alpha is equal to 9 plus 16. And so here we can factor out the R squared. We are going to have R squared sine squared alpha plus cos squared alpha is equal to 9 plus 16, which is 25. And so here in the brackets, we can see that we have this identity. So the whole thing will reduce to 1. And we are going to have R squared times 1, which is just R squared is equal to 25. And now we can find the value of R by getting the square root. So the square root on both sides. So this one will cancel with that. You have R is equal to 5. And so now, since the question says now convert this into R sine theta, therefore, our conversion now, R sine theta is going to be equal to, since our R is 5, we are going to have 5 here, sine, and then theta plus the alpha is the angle that we found here. The alpha is the angle that we found here, 36.9. So we are going to have 36.9 degrees. Okay, and then now we can now find the we can now go to part B of the question. We have converted this one. So part B of the question says, change this same expression here. Okay, so we are converting this same expression to 3 cos theta plus 4 sin theta to R cos theta minus alpha. So to R cos theta minus alpha. Okay, so in the same way as we converted this one here, we are also going to convert R cos theta. So we are going to expand this one using the identity for cosine, expanding cosine. So we are going to have R, this one will be R cos theta cos alpha plus, okay, so when you are dealing with cosine, the sign here changes when you are expanding to plus, and if you have the plus here, it changes to minus. So this is going to be R on the other side, sine theta sine alpha. So this is how we change this is how the identity is for this kind of a function. And so here now when we compare with the question that we have, we are told to convert 3 cos theta plus 4 sine theta. So we are going to compare on both sides of the equation. So we'll look at this one here on top and check the one that has cos theta. So cos theta is found on the left side here. So this cosine will cancel with that cosine on this side, and here you remain with R and cos alpha. So we are going to have R cos alpha is equal to 3, which remains here. And then we'll call this one equation number 1. And then we can also compare this one now with this other side, because this one has sine theta and this one has sine theta. And so we can cancel here also the sine thetas. Will remain with r sine alpha here. R sine alpha is equal to 4. And this is equation number 2. So we can find now the value of alpha here by dividing the equation number 2 divided by the first equation there. So we are dividing like that because we want sine to be on top, and it's because we have the identity for sine over cosine, which is tan. So we are going to have r sine alpha over r cos alpha is equal to 4 over 3. So 4 is on top because r sine alpha goes with 4, and it has to go with 4 there. So the r will cancel out in this case, and we are going to have tan alpha is equal to 4 over 3. And then we can find alpha here, tan inverse of 4 over 3. Okay, so we are going to find the inverse of tan here. So tan inverse of 4 divided by 3, okay, 3 there, divided by 3 will give us 53.1. 53.1. So alpha will be equal to 53.1 degrees. And then now we can find the value of r. We can now find the value of r by squaring both of these two equations and adding them. So we are going to have r squared sine squared alpha, so we square this one, plus r squared cos squared alpha is equal to 4 squared plus 3 squared. So again here, r squared or sine squared alpha and cos squared alpha will give us a 1. So we'll remain with r squared is equal to 4 squared is 16, 3 squared is 9, which will give us 25. And then we can find square roots on both sides again here, and we have r is equal to 5. And so therefore, to write in this form now, we are going to have our r, which is 5 cos theta minus 53.1 degrees there. In part B of the question, the question says solve the equation sine 2 alpha plus cos 2 alpha is equal to 1 over root 2 for alpha between 0 and 360. And so here, when we are solving an equation like this, the first thing is to convert this part here into the form r cos 2 alpha minus x. Okay, so when you see there's a plus here for cosine, you put a minus here, because after expanding this, we are going to have a plus. Okay, so here we are going to expand this one here. We are going to have r cos 2 alpha cos x plus r sine 2 alpha sine x. So this is the expansion of this function here. And so we are going to compare the expanded function here with the original function that we have. And then now we'll look for sine 2x in this function here, sine 2 alpha in this function. And so we see that it's found on this part of our expression. So remember that this one has a coefficient of 1 there. So we are going to compare these two, and then we'll cancel the sine 2 alpha there. And then here you will remain with r sine x. R sine x is equal to this one here. And this is our first equation. And our second equation on this part here, we are going to cancel cos 2 alpha here and that cos 2 alpha. Here you remain with r cos x. R cos x is equal to, there's a coefficient of 1 there which has remained. So 1. And you have 2 here. So now we are going to find our x here by dividing these two equations. We'll divide the first equation over the second one. So we are going to have r sine x is equal to 1 divided by r cos x over 1 here also. So these two ones here, we divide them. So the r will cancel out, will remain with tan x. Remember the identity for tan is sine over cosine, and this is equal to 1 here. And so x is going to be equal to tan inverse of 1. Okay, this one is a special angle. X is equal to 45 degrees. X is equal to 45 degrees, and then now we can find our r. And so the way we find r here is to square both equations that we have, equation 1 and equation 2, and then add them. So we are going to have r squared sine squared x plus r squared cos squared x is equal to 1 squared plus 1 squared. So you square this one, add them, square this one, and square this one, and add them. So sine squared plus cos squared is 1, so we'll remain with r squared is equal to 1 plus 1, which will give us 2. And then we can find square roots on both sides, and therefore r is equal to the square root of 2. And so our function now in this form is going to be our r is root 2 cos 2 alpha minus our x is 45 degrees here. And so we have it in this form. Now we can solve our equation. Okay, so now let's solve our equation now. So since the original equation has an equal sign here, which is equal to 1 over root 2, it means that even the one that we have found here, because it's just another form of this one, is going to be root 2 cos 2 alpha minus 45 is equal to 1 over the square root of 2. Okay, so here, since we have 1 over the square root of 2, we are going to multiply the reciprocal of this square root of 2 that we have here on both sides of the equation, so that we get rid of this one here. So we are going to have, this is over 1 here, so the whole thing over 1. So we are going to multiply by 1 over root 2. Even this side we'll multiply by 1 over root 2, okay, which is the reciprocal of this one, so that we get rid of this root 2 here. So these two will cancel out, will remain with cos 2 alpha minus 45 degrees is equal to 1 times 1, there is 1. The square root of 2 times the square root of 2 is just 2. Okay, so at this stage now, we are now going to find the inverse. So we are going to have 2 alpha minus 45 is equal to cos inverse of 1 over 2. Okay, so this one is also a special angle. It's just 60 degrees. So we are going to have 2 alpha minus 45 is equal to 60 degrees. Now, since half is positive and the cosine is positive in two angles, let me draw the diagram here for quadrants. Okay, so we are going to have here we have 0, 90, 180, and then 270 here. And so since we have 2 alpha here, it means the cycle will go again. So 360 plus 90, we are also going to have 450 here. 450 plus 90, we are going to have 540 here. 540 plus 90, we are also going to have 630 here. And the 630 plus 90, we have 720 here. So this range that we have included now is because we have 2 alpha here. And so the original range that we had was this one here, 0 to 360. So you multiply these 2 times all these numbers here, you get to 720 here. And so it means our angles here in the second quadrant, in the first quadrant here, where we had 60, we are going to have 2 of them. So the next thing now we are going to do is add this 60 plus 360 here. You are going to have 420. And also, since cosine is also positive in the fourth quadrant, you are going to have 360 minus 60, which will give you 300. And then 360 plus 60, you are going to have 420. And then you are going to have 720 minus 60, which will give us 660 here. And so we can calculate now the value of alpha by using this. So we are going to have 2 alpha is equal to, here we take the 45 this side. So 60 plus 45, because it becomes positive this side, we are going to have 105. And then 300 plus 45, we have 345. And then 420 plus 45, we have 465. And then 660 plus 45 here, we are going to have 705. And then we can divide all these by alpha here. We're going to have alpha is equal to, and then we can divide all these by alpha, which will give us, okay, we bring on our calculator here. We are going to have 105 divided by 2, which will give us 52.5, and then 345 divided by 2, which will give us 172.5, and then we also have 465 divided by 2, 465 divided by 2, which will give us 232.5, and the last one is 705 here, 705 divided by 2. So 705 divided by 2, which gives us 352.5. And so these are the values of alpha that we are looking for in this question. Thank you very much for paying attention.